Linear function. This is the simplest non-constant function you can graph. Its rule is f of x equals x, and it produces a perfect diagonal line with a slope of 1. In its base form, it will always pass through the origin, and in turn have a y-intercept of 0. We can make it easier if we allow out all of our possible transformations in the equation before graphing, which would be f of x equals a, parentheses x minus h, and parentheses, plus k. To represent a vertical shift, we add or subtract to x, represented by k. For example, f of x equals x minus 3, or f of x equals x plus 3. This will not change the slope, however. To represent a horizontal shift, you add or subtract to the function of x, represented by h, where if h is greater than 0, it represents a horizontal shift to the right, and if h is less than 0, it represents a horizontal shift to the left. An example could be in parentheses x minus 4, where it moves to the right, or in parentheses x plus 4, where it moves to the left. To represent a vertical stretch or compression, we multiply x by another number. To represent a vertical stretch, it has to be greater than 1. For example, f of x equals 2x. To represent a vertical compression, a has to be less than 1. Example would be f of x equals 1/2 x. There are some special cases where a horizontal line can be produced when a equals 0. To represent a reflection, you either transform x into its negative component or f of x into its negative component, depending on whether you want to reflect in the x or y axis. Quadratic function. Its rule is f of x equals x squared, and it creates an arch much like the one you see in America called the parabola. In its base form, the vertex will lie on the origin, and its axis of symmetry will be on point 0 in the x-axis. To represent all possible transformations, I'll write it as f of x equals a, parentheses, x minus h squared plus k, where each letter represents the same type of transformation as the previous linear function. A vertical shift of 3 would look like f of x equals x squared plus 3, where k still and will always represent the vertical shift. A horizontal shift of 3 would look like this, f of x equals x minus 3 in parentheses squared, where h also still represents what it did before, a horizontal shift. A vertical stretch of 3 can be expressed as f of x equals 3x squared, and a will represent the stretch or compression. If a, your vertical stretch/compression value, is less than 0, the function will be reflected across the x-axis, such as in f of x equals negative x squared, where a equals negative 1. From now on, we'll be plugging in the value of the relative transformations into the equations by default. Cubic function. The parent function for all cubic functions is f of x equals x cubed. This is the s-shaped function that passes through the origin in its base form. For our possible transformations, I'll write it as f of x equals a, parentheses, x minus h cubed plus k. A vertical shift of 4 can be expressed as f of x equals x cubed plus 4. A horizontal shift of 4 can be represented as f of x equals, parentheses, x minus 4 cubed. A vertical stretch of 4 would be written as f of x equals 4x cubed. A vertical compression of 4 can be represented as f of x equals 1/4 x cubed. If a, your vertical stretch value, is less than 0, the function will be reflected across the x-axis. An example would be f of x equals negative x cubed, where a is negative 1. Absolute value. This is the v-shaped function. It will have its vertex at the origin in its base form, and it can be simply represented with f of x equals the absolute value of x. Or to show our possible transformations, f of x equals a, the absolute value of x minus h plus k. A vertical shift of negative 2, or 2 to the left, would be written as f of x equals the absolute value of x minus 2. A horizontal shift of negative 2, or 2 units down, can be written as f of x equals the absolute value of x plus 2. A vertical compression of 2 can be written as f of x equals 1/2 of the absolute value of x. And a vertical stretch of 2 would be written as f of x equals 2 times the absolute value of x. A reflection across the x-axis would be f of x equals negative the absolute value of x. Square root function. F of x equals the square root of x. The shape displays a slope that seems to increase at first, but shows diminishing returns as x gets larger. Its curve looks like a half-sideways parabola. It can also be expressed as f of x equals a times the square root of parentheses x minus h plus k. To show our transformations. A vertical shift of 2 is written as f of x equals the square root of x plus 2. A horizontal shift of 2 can be written as f of x equals the square root of parentheses x minus 2. A vertical stretch of 2 is written as f of x equals 2 times the square root of x. And a vertical compression of 2 would be written as f of x equals 1/2 of the square root of x. Cubic root function. F of x equals the cubic root of x. It looks like the same S-shaped curve as a cubic function but sideways, almost like an actual S. It passes through the origin and is defined for all real numbers. It's symmetric about the origin and shows increasing returns further from the origin. It can also be expressed as f of x equals a times the cubic root of parentheses x minus h plus k. A vertical shift of 2 can be written as f of x equals the cubic root of x plus 2. A horizontal shift of 2 can be written as f of x equals the cubic root of parentheses x minus 2. A vertical stretch of 2 will be written as f of x equals 2 times the cubic root of x, and a reflection across the x-axis is written as f of x equals the negative cubic root of x. Reciprocal function. F of x equals 1 divided by x. I don't know how to describe the shape of this one to you, so I'm just going to show you. To preface, an asymptote is a straight line that a curve approaches as one or both of the xy coordinates tend to infinity. For this one, the vertical asymptote is x equals 0, and the horizontal asymptote is y equals 0. It could also be expressed as f of x equals a divided by parentheses x minus h plus k. A vertical shift of 3 could look like f of x equals 1 divided by x plus 3. A horizontal shift of 3 could look like f of x equals 1 divided by parentheses x minus 3. A vertical stretch of 3 would look like f of x equals 3 divided by x. And a reflection across the x-axis would still just be f of x equals negative 1 divided by x. Exponential function. F of x equals b to the power of x, where it's important to point out that b has to be more than 0 and cannot be 1, so it's more commonly expressed as f of x equals 2 to the power of x. This function looks something like a steep curve. It's special as it's our first function to pass through the 1 point on the y-axis on its own. It has a horizontal asymptote at y equals 0, and the steep curve will be increasing if b is more than 1, and decreasing if b is more than 0 but less than 1. To display our transformations as usual, I'll write it as f of x equals ab to the power of x minus h plus k. A vertical shift of negative 3, or just 3 downwards, would be f of x equals b parentheses x minus 3. A horizontal shift of negative 3 would be f of x equals b parentheses x plus 3. A vertical stretch of 3 would be written as f of x equals 3 parentheses x. And a vertical compression of 3 would be written as f of x equals 4 divided by 3x. A reflection upon the x-axis would be written as f of x equals negative bx. Logarithmic function. F of x equals log b times x, where once again b is more than 0 and b cannot be 1. The vertical asymptote is x equals 0. It passes through 1 on the x-axis as increasing if b is more than 1 but decreasing if b is more than 0 but less than 1. It's the inverse of the exponential function. To display our possible transformations, I'll write it as f of x equals a log times parentheses x minus h plus k. To represent a vertical shift of 3, it's f of x equals log b times x plus 3. For a horizontal shift of 3, it's f of x equals log b parentheses x minus 3. For a vertical stretch of 3, it's written as f of x equals 3 times log b times x. For a vertical compression of 3, it's f of x equals 1/3 log b times x. And for a reflection across the x-axis, it's f of x equals negative log b times x. Thank you for watching.